Hello, students. We are going to be learning about the number family, from the rational to the irrational and every other imaginable things. So let's begin talking about the number family. I'm going to kind of draw like a family history chart of this number family. And so we have here the number family. Move this up and out of the way. Now, the number family, the mom and dad of this, basically had two children. One was named real or real numbers. And the other child was, if it's not real, it's imaginary. Imaginary. So they had some imaginary children. And they're kind of a complex number. Okay. So we'll get to that maybe in 1010. Well, actually, you do get to it in 1010. But the real number family, they had two children. And those children were, one was very rational. And one was an irrational number. And rational numbers, they gave birth to something called integer. Numbers. And integers, well, they gave birth to basically what we call whole numbers. And it's not really that they gave birth, but this is just the line of how it works. And whole numbers, well, technically they came from, this is kind of your family history going backwards. They came from what we call counting numbers or natural. So let's start from the bottom and just kind of talk about these numbers. Natural numbers were the numbers that you grew up learning to count with. You naturally started at 1, and natural numbers start at 1, and they are complete numbers. There's no fraction part to it. So it's just 1 and counting, and you could get up to infinity. And we usually notate that with a big N, and sometimes it's got a double there. The natural numbers would be this set of numbers all the way up to infinity. Okay. The whole numbers include the natural numbers, so they include everything below them, plus 0. So they include 0. Now, if you notice something, 0 is not a natural number, but all natural numbers belong to the whole number family. But not all whole numbers belong to the natural family. An exception would be 0, right? The next thing is we get is the integers family, and that's done by a capital Z, usually with a double bar right there. And the integers family include all whole numbers. So everything below it includes that. But it also includes their opposites. And we've already talked a little bit about opposites. The opposite of 3 is a -3. The opposite of 4 is a -4. Opposite of infinity is a negative infinity. And so we have that list of numbers going that way. But notice there's no partial numbers. They're all whole numbers until we get to the rational numbers. And rational numbers can be made by making fractions with any integer numbers. So P over Q as long as Q does not equal 0. It cannot equal 0 because then it's undefined. So a fraction would be a rational number. We can also tell a rational number. I'm going to erase this irrational for now because it's kind of getting in the way. We can also tell an irrational number, or sorry, a rational number by the fact that it's a decimal number that terminates. In other words, it ends. For instance, 0.012. It ends, doesn't it? We can also determine a rational number. It is a rational number if it is a repeating number. And it just keeps repeating. Then we call it a repeating decimal number. That is also rational. Okay, and we would actually shorthand write that as 0.32, and we would part a bar above the 3 into 2 because that's the part that keeps repeating. Okay, so far we have natural numbers. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers, and all rational numbers are real numbers. Now remember, I said there was a second family member. Let's take him over here and draw him. And that is the irrational numbers. Now, I would highly recommend drawing something like this or some kind of way for you to remember these numbers because you will have an assignment where you're going to be asked to identify it. If I gave you the number -2 and I asked you what number family it belongs to, you could say that it belongs to the integers and anything above it. Okay, but notice it does not belong to whole numbers, negatives. There's no negatives in whole numbers, and there's no negatives in natural numbers. So it doesn't belong to those two families, but it does start at Z, and it does appear in the rational numbers. Okay. However, irrational numbers are numbers like pi, e, square root 2, or numbers that never end. They're a decimal number that goes on and on. There's no repeating like we had here at 3232. It doesn't end finality like that. It just keeps going on, and you keep dividing with it, and it just keeps going on. So rational numbers are pi, e, radicals, and we'll talk more about that later in chapter 7 or module 7, and or numbers that never, they're numbers that never end. Okay, so like root 3, square root of 6, all of those, they do not have a perfect square, and so they would be called irrational. Their decimal number continues on and on. Okay, and then there's the imaginary numbers, which we will not get into. Another way of looking at this particular chart is to draw a diagram where we start with the smallest set. Looking at this, the smallest set would be the natural numbers, wouldn't it? Then the whole numbers, then integers, then rational, then real, and then we have the number family. So let's look at that. Draw a different way. So could start out here with natural numbers. All natural numbers are every other kind of number too. If you can find it in the natural number, you can find it in any other kind of number. So I'm going to put a little circle around that. The next number we're going to talk about, once again, would be the whole numbers. And what makes them whole? Well, you got to put the whole in it, or in other words, the 0. So in natural numbers, we have 1, 2, 3, 4. In whole numbers, we add 0 is the next part to it. 0 plus everything that's in the natural numbers. Then we have integer numbers. And they include everything that's in natural, everything that's in whole, plus the negatives. Okay? After integers, we got rational numbers. Find us a different color for that. Now, rational numbers, notice it's got a lot more members in it because it includes natural numbers, whole numbers, integers, and rational numbers, which were, I could write them as a fraction, right? P over Q, terminating decimals, and repeating decimals. And then we got to the real. Now, before I'm going to draw the real family. Let's go ahead and do that. I think we'll go purple. No, we're going to go lighter blue. The real numbers include all the natural numbers, but they also have this set of irrational numbers over here. Like pi and e and √2 and √3. Okay. And then, of course, we had our number family. And let's go ahead and do that in black. And it includes everything, including the branch of the family that we don't talk about much, which is the imaginary, represented by the little letter I. So there is another chart. So if I gave you the number 0, tell me the families it belongs to. Well, it's not in the natural numbers, is it? But it is whole, integer, rational, okay, and real. We got to write real here. So natural numbers are found in natural numbers, whole numbers, integers, rational numbers, and real numbers. However, they're not found in irrational numbers, okay? But they're kind of their own little thing. They don't belong to this other grouping here, okay? And so you could see how each number set gets a little bit bigger, and then there's this one off by itself and this really a lonely one, the imaginary numbers in the whole number family. So here we have these numbers. So what I'd like you to do for an assignment is create your own one of these, and then you're going to submit it, but you're also, I want you to make sure it stays in your notebook so that you can refer to it throughout the weeks that we're going to be together. Hopefully you have a great day. Thanks for joining me, and happy hunting with your numbers, and good luck with all that you do in this class.